Hello, my name is Nicholas Sponsel from North Carolina State University. I am presenting influence of submerged bubble proximity on the electric field in water. This work was carried out by myself, Maria Herrera-Quesada, and Dr. Katarina Stappelman with the Plasma for Life Science Research Group at NC State University, Department of Nuclear Engineering, and also with Dr. Sophia Gershman at the Princeton Plasma Physics Laboratory. We are interested in plasma and liquid interactions, particularly under the boundary conditions of submerged bubbles. In our experiment, bubbles were allowed to flow freely from the gas feed nozzle and pass between two electrodes driven by a high voltage pulser. Due to the free-flowing nature of the bubbles, effort in defining their fluid dynamic conditions was carried out in our previous work to control for the bubble position and shape. The electrodes were then positioned around the stable flow of the rising bubbles. The result of this is a minor variation in the electrode position with respect to the bubble and the water layer thickness between the apex of the bubble and the tips of the electrode. If we imagine the bubble, water, and electrode as a capacitor, it is clear to see that changes in the dielectric thickness and the distance between the electrodes can alter the electrical behavior of the system. For this reason, we model the electrode in the bubble system in ANSYS Maxwell Field Solver, then alter the bubble to assess changes in the field in the bubble and at the tips of the electrodes. We present the relative relationship between the two fields as our virtual bubble is displaced further from the electrodes to account for discharge in the region of the water observed experimentally. We found that there's a minimum water thickness in which the field of the bubble is greater than that at the tip of the electrodes. This may help inform us of when discharge can be preferentially targeted in the gas region for fast rise nanosecond high voltage pulsars. Likewise, for our future work, we also investigated optimal bubble sizes for the electrode distance by shrinking the bubble size to determine when the bubble greatly affects the electric field at the tip of the electrodes. Thank you.